Let's continue with an example. What I did was I collected data from a Math 120 class I taught a number of years ago, and from that data I took, from that class I took the number of absence each student had, that represented the X, and Y represented the final grade in the class. So I just randomly chose 5 of the students to illustrate how we do go about finding the correlation coefficient using the formula. So the first person I selected had 2 absences and a 95. The second one I selected had 6 absences and an 81. The third one had 2 absences and a 95 at the end of the semester. The next one had 11 absences and a 50 at the end of the semester. And finally, the last one had 5 absences and 75 at the end of the semester. So what we want to see, is there a correlation? Is there a relationship between the number of absences and the final grade in the Math 120 class? So because of the formula, if we take a quick look at our formula down here at the bottom, we need to know the product of x and y, the x squares and the y squares, and we need to add up all of these columns. So I went through and computed x times y. I squared x's, I squared the y's, and then I summed up all these columns. So it took a little while to do the computations. Now, what I want you to do is I want you to plug the numbers in. I'll try to do this so you can see it, to see if you can come up with the correlation coefficient R by using the formula. And so what I want you to do is pause the recording and figure out a value for R, and then you can restart it. And notice my directions are to round R to 3 significant digits. That's what we normally do. So go ahead and pause the recording and see if you can come up with a value for R, and then restart it and we'll see if we can come up with a value for R as well. Okay, hopefully you have come up with, and I notice now that I should have put this in here, but let me get my ink tools. Should be a square root in the denominator around these. There we go. Square root. So I know that may have changed your answer. All right, now you're probably going to hate me, but I'm going to put the numbers into the TI Smart View. Yes, we can make our way through these and calculate all of them, but I'm going to show you with the calculator. I'm trying to move my window if I can. And it looks like it may not move. Oh, there we go. I got it by the corner. Alright, so what I want to do, down just slightly, is I'm going to clear what I have here and quit the graphing mode. Clear. And what I want to do is I want to go to Edit, and I'm going to clear this column. And what I want to do is I want to put the values that I have on the sheet. I want to put those values in here, so I'm going to put absences in the first column and their grades in the second column. I believe the first one was like 2. And let me move over here. I keep forgetting I can't do 95. Alright, let me look back at my lecture sheet. Okay, I had 681 and then another 295. Okay. Alright, 6. just going to put the 95 in there. Go back over and do the 2. Alright, and then my last two, let's see, 1150 and 575. Okay, so we have our x's in L1, our y's in L2. Now we go to stat, and we want to calculate. This time I want to do linear regression, so I'm going to choose number 4, and I have to tell it which columns to use, so I'm putting L1, comma, L2. Alright, now what you'll notice about this calculator, and if yours is the same, then we need to take care of something and then redo it. So what we have to do is we have to go to our catalog. So I'm going to go second catalog, and I need diagnostic on. So let me scroll down here. Okay, I went too fast and got past it. Here we go. We want diagnostic on. So I want to press enter and enter again. It says it's done, so now let's try it with, okay, I want again number 4, linear regression, L1, comma, L2. Notice that the first time I only had values for A and B. I didn't have a value for R squared and R. And notice what I got for R, negative 0.9778. So that would be rounded to negative 0.978. That is what you should have gotten with your formula. Okay, so we go back. Move my window back over. And our value for R squared was I want to say it was 0.956. I may be wrong on that. Oh, that's right. Okay, so back to the... Alright, now this is my correlation coefficient. This is my coefficient of determination. So what do these two tell us? Well, first of all, the correlation coefficient, we have to go to table A6 and see if the absolute value of our R, we want the absolute value of our R to be greater than the table value. Then that means we have linear correlation. Okay, it's significant enough to talk about it. If our absolute value of our R is less than or equal to the table value, then that means that we do not have linear correlation. So I'm going to go to a page where I have the table showing, hopefully. I may have to move my window again. Okay, I'm going to have to move my window slightly. Alright, so this is table A6. It's the critical values of the Pearson correlation coefficient. And I know they may be fuzzy. I have them increased by 170%, but anyway. We go to 5. There were 5 ordered pairs, and we see 0.878, I believe is what it says. So I'm going to go back to my lecture notes, move my window back. Table value is 0.878 for alpha equal to 0.05. That's what we're told to use. So the absolute value of RR is greater than the table value, so that means we do have significant linear correlation. The absolute value of negative 0.978 is greater than 0.878. Therefore, we have significant linear correlation. So there is a relationship, we know, between the number of absences and the final grade. The negative in the R tells me it is a negative correlation. It's a negative correlation in this case. Now, what about the coefficient of determination? Well, the coefficient of determination tells us what proportion of the variation in the final grade can be explained by the relationship between the number of absences and the final grade. And it turns out that about 96% of the final grade can be explained by the number of absences, at least with the data that I have here. So we actually have done the same problem with the TI-83. I made you do the difficult part. I had you do it with the formula. And knowing that most of you will never again try to do it with the formula, I did it with the calculator. And we'll leave stat disk. Perhaps we'll do that at another time, but I think I'll leave that off for now.